All right, so for this office hour, I'm going to start with talking about things to think about when putting together a presentation. A lot of the presentations last round went a little bit long, and it is kind of a skill to learn how to be concise to a non-technical audience and really putting yourselves in the shoes of your audience to figure out what is worth keeping up in a presentation and what isn't. So I'm going to be going through some of that. So this template, it might look familiar because it's the exact same one that I had for the last project, but I did add a couple notes and thinking points for you all. And again, any questions or any clarifying things, just let me know. Feel free to interrupt. So to start, again, title slide. I think that's pretty self-explanatory. Have your name on there. Next, go into your overview, your why, your motivation. Why you're doing this analysis or a preview of your results. Why is this classification problem important? Are you building your classification model to either make predictions on, things that haven't happened yet, or are you using your classification model for an analysis purpose? So from classification models, again, depending on which models you do use, you can actually extract a lot of information about your data set, and maybe you're just deriving insights from the models that are being trained. That is also an acceptable motivation. So keep that in mind, especially for, I think there are a couple of people doing more like social context kind of problems, like the Terry stops data set's a really, really good one for just like deriving patterns in your data. And again, possibly a preview of results. Why I say this here, and not everyone does this, and again, it's really up to you and like, I think that you all know the story of your project best, and however you think is best to present that narrative, do that. And so for some people this works, some people it doesn't. This is another pretty self-explanatory slide, a brief overview of your data. What are your sources? Did you use a provided data set or like API or web scrape? And a really high level snapshot. I would say like in terms of high level snapshot for this project, a really good one would just be like, how many points are in your data set, and are they like, how are they proportioned across the different classes? So do you have a serious class imbalance, or are they pretty balanced across your classes? So yeah, I say this here as well, distribution of your target class. That's a pretty basic one to have, because usually when you're presenting a model to stakeholders, they want to know what your underlying data is looking like. So imbalance bounds, maybe some percentages. So this, I would say, is pre-EDA. I said this is just like really basic before you go into like your feature analysis. For the EDA, I think this is where a lot of people struggle with like, all right, what's worth putting in here, what isn't? Again, the rule, I think like a key point to remember is it's good to have EDA that is relevant to your analysis or your modeling. And I'll get back to a little bit of this later. And as usual, feel free to annotate if needed. It is possible to actually, like highlight certain bars in a bar graph using Matplotlib, but 100% acceptable to just use the PowerPoint tools to just like create boxes and arrows. So with your EDA visualizations in your notebook, you can go ham. You can do all the visualizations you want. The more visualizations you do, you probably will learn more about your data set, so that's good. However, when you're doing a presentation, you have to think, all right, what visualizations are actually going to matter to the stakeholder? And there's several ways of going about this. So let's say you're doing a problem like the Chicago car crashes data set. If you're trying to predict like the severity of a car crash, 2 ways to go about it. One, think about what would people think about first. When you're trying to predict the severity of car crashes, what are some of the features that you think that people might have a hypothesis about? Like probably like weather conditions. And so maybe show the distribution of weather conditions that will either, I guess, either confirm people's hypothesis that like in rainy weather, car crashes are more severe, or maybe you can show this and say like, maybe it isn't a big factor when it comes to the severity of car crashes. So you can do this EDA and you can sort of create this EDA narrative by using some hypotheses that maybe you yourself had at the start of the analysis. Another way to go about this is also after your modeling. So after your modeling, you can from most models, you can get a lot of feature level analysis done. Like for example, what the most important features are from any tree model, or some of the coefficients if you do logistic regression, or some of the probabilities from like your naive Bayes. So using that information, maybe that can guide your EDA. So maybe you get your most important features, even though it's a little bit out of order, having that to be your EDA would tie your modeling together better with your EDA. So here again, don't just do a histogram dump. Often if you just show the distribution of all your variables, and in this project, I know a lot of you are dealing with like more than 20 variables, it won't be very, very useful or like value added to just dump all your histograms here. Yeah, really just think about what your audience would be curious about, and also perhaps guided by your model results. So again, the two approaches of like maybe going off people's curiosities or people's hypotheses, or guide it with your model results. And also, I think this might be a good place to mention your feature engineering. At this point, any questions so far? All right, so we haven't even gotten to the modeling step yet. I would say with EDA, it's good to have maybe maximum like 3 bullet points that you're going for, just so you keep it concise and you really narrow it down to the most important things. And let me just write that down here. 3 bullet points with your EDA. There we go. All right. So with your models, the expectation is you're going to be running at least 4 models, and with at least 4 models, you're going to be running way more than 4 models in total. So with this, present your final model, or an intermediate one if you think it adds to your presentation. I will say most of the time, intermediate models don't really help with your presentation. How does it compare to your baseline or of some of the other models you ran? So a couple ways that I've seen that are pretty effective ways of showing these results. Maybe you have like, you know, your data frame of all your model results, and then you just like circle the best ones. That could be one way to show why you chose those models. Or another way is just show your final model results. Show your like confusion matrix is usually a pretty solid visual to have there. And yeah, compare it to your baseline. This might be a good place to also talk about your metrics. Like for example, if you chose to focus on something like recall, maybe a quick 1 to 2 sentences saying why recall and what that means as non-technically as you can. And yeah, let's see what else. Yeah, a quick 1-2 points about how the model works. So if you chose like a random forest, I think that stakeholders would like to know roughly how the random forest works. So I wouldn't go too in depth with this. I would just say that you're training a bunch of decision trees, and decision trees work by looking for ways to segment your data, something like that. And yes, why did you choose this model? Because of a certain metric. And again, that's a good opportunity to explain the metric. And then finally, evaluate your model and interpret the metric. So if you had like an 80% accuracy overall and maybe like a 50% recall, maybe explain that a little bit. What does that mean in context? So what are the contextual implications of your model? So again, maybe if you're doing like a virus detection model, having a recall of 50%, what does that mean in your context? And again, misclassified points, again, it is pretty context driven, but if this is, if you think that this is a worthy thing to mention, do mention that as well. What do the misclassified points mean? Like what, in this case, what are false negatives? What are false positives? Or if you have multi-class problems, what would a misclassification in each thing mean? And I think, especially with multi-class problems, having the confusion matrix usually makes it a little bit clearer. While giving the presentation, don't assume that everyone knows how to read a confusion matrix. So as you're giving the presentation, again, because I will be recording it, some people might choose to use a recording in their like LinkedIn or whatever. Good to just mention really quickly how to read the confusion matrix. Questions at this point? This slide does have a lot, and I expect like this slide to maybe be in like 2-3 slides. All right. Well, after this point is pretty much the same as the last presentation. Summary and conclusions. This is the same, summarizing all your insights and overall recommendations. Whenever possible, now this is something that I guess I didn't really emphasize the last time, but we want to make our recommendations very model or data driven. So your recommendations, again, model driven, what are the most important features? That's usually connected to that. Or data driven. If you ended up choosing a model that you can't get direct insights from, or it's a little harder to extract insights, like for example, if KNN happens to be like your best model, maybe do some more data driven recommendations. You would have to do a possibly like a post modeling EDA, take a look and see like what features, I guess this is not the correct technical term, but what features correlate most with the targets. And I'll talk about correlation in a point later on as well. And the rest are the same, any next steps, and then your thank you slide. Cool, so with this, I just wanted to emphasize like narrowing down your EDA and really thinking about what graphs make sense to a stakeholder for your presentation. Again, if you ever wanted, I'm more than happy to take a look at your presentations on, I guess, Monday morning, if anyone wants to send it over. Or if anyone wants to like put together a presentation this week, I don't know, it depends. But yeah, happy to look these over. And yeah, for modeling also, I think this one has a very different approach to presenting your modeling compared to the last project. All right, any questions before we move on from these presentations? Cool. Again, for our presentations, I do have it split up across 2 days, Monday and Tuesday, when we get back, which will lead me to another thing that I'm going to make a note for myself to mention to you all. But yeah, all right, I'll remember. All right, so let's get to some of these questions. Awesome, really happy to see a bunch of questions here. All right, so first one I see is, any guidelines or rules of thumb on how large a class imbalance needs to be before you do something about it? Typically, if you find that your model is fully predicting your majority class, then you need to do something about your class imbalance. So how models work with class imbalance is not so much based on, the percentage of your data points in each class. It's really more about how separated those data points are. So you could have like 99 and 1 class imbalance, but if in the feature space, imagine if you had just 2 dimensions, your majority blob is here and your minority blob is all the way over here, you'll still get a pretty good classification result without having to, you might have a pretty good classification result without having to do any like smote or anything like that. So it's really about like how separable your data is. So therefore there's no like straightforward way of saying like, all right, if you have more than like 80-20 split, you have to smote. So it's really more about how separated your data is in feature space. So it's a little bit harder on that front. So yeah, if you find that your models are only predicting your majority class, and for some models that feel the case, I know that KNN and logistic regression and decision trees have a tendency to do that. If you have a class imbalance, they have the tendency to just predict all the majority class. So your confusion matrix will look like all the numbers on the left side and then zeros on the right side, meaning that they're not predicting anything to be of the minority class. If you see that happening for more than 2 models, you definitely want to do something about it. And yeah, so let me just type this up. No, what's the word? No threshold, is that the word? There's no no limit to class imbalance, but as long as your models are always predicting the majority class, good idea to smote. And again, this is because it matters more about the separability of your data. Separability of data affects this more. and the proportions. All right, any questions about this? I know a lot of you are dealing with imbalanced data, so this is definitely something to talk about. Let me actually then move, where did I talk about? Oh, right here. Okay, that's a good place to have it, right under these things. So I do believe that I talked about removing TOMEC links last week on Friday, I think, and also SMOTE is over here. So resources for you to check it out. Again, SMOTE just oversamples your minority class by creating synthetic data. TOMEC links helps with the separation of your data. And something that's pretty cool, you can actually combine the two. So let's say you have a very, very severe class imbalance. What you can do is you can remove TOMEC links. So run your TOMEC links maybe a couple times so that you can remove some majority points such that you get a little bit more separation. And then you can create, then you can SMOTE your minority class to get a better balance. So you can definitely stack the two if you'd like. Any other questions on imbalanced data before we move on? Let me see if there's anything else that's about imbalanced data here. Let me move this up so it's in the same category. There's a question here about, is there a reason to SMOTE oversampling or vice versa? Okay, so between the different ways of balancing your data. So there's SMOTE, there's oversampling, there's undersampling, there's this TOMEC links over here. It's really up to you. It is honestly like try them all and just see which works better, because it is kind of hard to determine like how separate are my different classes in feature space to begin with. We haven't really learned about like ways to check for that. So therefore, yeah, I would say it's more of like a try everything, check results. Again, like there are some pros and cons to over versus undersampling. So with oversampling, the cons are if oversampling being like SMOTE, if your classes of data are already very overlapping, if they're not very separable, doing SMOTE might not help because you're just creating more data points in the same region and it's not going to help with the separation of your data as much. With undersampling, the con is you lose some data. In your undersampling, especially if you have like a very severe class imbalance, let's say you have like 100,000 points of zeros and only like 1,000 ones. Undersampling your majority class to also be 1,000 is such a small proportion of your data that it's very hard to say that your 1,000 will be representative of your 100,000. So that is one thing to look out for. With undersampling, I know a strategy that some people have done is to just take different undersamples and just test to see if their model results are very different. It's sort of like a way of cross-validation. I personally haven't really done that, but if you do decide to undersample that, with that method, that could be a way to check to make sure that your undersample sample is not biased in some way.
Excuse me, Ish. When I was searching, I ran into something like auto-encoders, if I'm not mistaken. Are we going to learn that, or we can use it in this project?
Autoencoders is a very, very broad umbrella term. Autoencoders is just like the umbrella term for like encoding something as something else. So we don't have something that is specific. We don't have a lesson that's specific on autoencoders. So I think anything that you come across in your research, by all means, feel free to use it. You're definitely not limited by what we have here. You're more than welcome to do your own research and incorporate things that you find. Yeah, but on autoencoders, I'm not sure which specific ones you found, but if you want some insight, feel free to send them over.
Okay, thanks.
You're welcome. Any more on class imbalance? Okay, so here there's a question about having a lot of columns. So 40 columns, mostly categorical. Even if you get rid of half of them, you have 20 columns, and if you one hot encode each of them, you'll have about 200. Will that be too many? Should I be more judicious in narrowing down my features? 200 is not too much. your models might take a little bit longer, but 200 is actually not too much. And I can say that because the same models have been used with text data, and with text data, you have like thousands of columns, and models actually run, like, it doesn't take too long to run. I think maximum your models might take an hour depending on how many rows you have, but that's not considered very long. So I think that is okay. It's not going to be too long. So yeah, being mostly categorical is also not a big issue. Yeah, that's not too much. Should I be more judicious in narrowing down my features? Typically, yes. If you're building a model to be used in the long term, you don't want your model to have to look for features that are not going to be important. But that becomes an iterative process, very, very similar to what we were doing with our linear regression. So let's say your final model ends up being like an XGBoost model, but you have 200 columns. Through your XGBoost model, what people typically do, you just take a look and see the feature importances. And if you have features that have a very, very small ratio that they're contributing to the model, you can just drop them. So yeah, it would be more of an iterative process. And again, that's just so your future models won't take as long. So yeah, I would say for this project, I wouldn't worry too much about narrowing down your features and the iterative process through each model. But yeah, that's good for you all to know. Let's see. Is there anything related to this? I do want to talk about, I think that this might be a good place to talk about confounding variables. So confounding variables are something that can harm your model. And actually, this is also related to the next question, best ways to see relationships with categorical variables and a binary target. So as a quick overview, what are confounding variables? Confounding variables are when your target variable influences some of your predictor variables. So let's say if I'm trying to predict, I think I saw the example that some of you were talking about with Terry stops. So in the Terry stops data set, I think, and let me just pull up to see what the exact ones were. I think, right, so there is stop resolution, and then there is arrest flag. So I'm not too sure about the context of the data, but one might be a result of the other. Let me just use, actually, let me change an example to use something that is more, that I can talk about in more detail. So let's say I'm predicting, I don't know why this popped in my head, but the outcome of like a sports game. So one of my past students did this project where they tried to predict the outcome of a hockey game, but one of the columns that they were using was the point differential between the two teams at the end of the game, which pretty much can perfectly predict whether the team will win or lose based on the point differential, because hockey is scored in points, and correct me if I'm wrong. So having a variable that is influenced by your outcome is a confounding variable, and you really don't want to have that, because you can't get the point differential without also getting your target, if that makes sense. If anyone needs to clarify, please let me know. So what this means is when you're going through your data, and because, you know, for these data sets, you get to choose what the target is, be very wary that none of your other variables are a result of your target variable. Some fixes to this, you can either drop the variable. If you have something that's more like a time series looking thing, and I know we haven't talked about time series yet, but let's say you want to talk about a team winning or losing that hockey game, maybe not using this point differential, but maybe use the point differential from their last game. So it's not exactly like, so your win or loss is not predicted by the point differential, because those are things that are directly not correlated, but it's an exact cause and effect. If you have a positive point differential, you're definitely going to win. So that's something to think about. Or if you have like maybe point differential at like the halfway mark of the game, maybe that makes more sense. But again, depending on how you're planning on using your predictive model. So confounding variables, something to definitely think about. If you find yourself having extremely good results that you're like a little bit suspicious of, like, why is my model doing so well? That might be something to look into. Which brings me to the point of like, how do you check these relationships with all categorical variables and a binary target? So confounding variables very, very often have are extremely correlated to the target. So several ways to do this. This article does talk about, and I do think this might be the easiest way to do it because a lot of you are dealing with a lot of different variables. You can actually use your VIF scores. VIF scores, again, work better for continuous variables, but if you have like continuous versus a categorical, you can still get some sort of score. But then again, your benchmark is not going to be as low as, I think 5 was what the benchmark was for linear regression. I honestly don't really remember off the top of my head. The most scientific way to go about this is honestly using statistical tests, because you want to see if they're related to each other. So a couple that you have here that we did talk about the Anova test. So an Anova test can tell you whether there is some dependence between the variables. So really all you can, what you can do is you can run them through an Anova test. If you get a p-value below 0.05, they are related. They are not related. I honestly forget which way it is. P-value will tell you that they are different, I think. I'm not, yeah, I think so. I would have to, yeah. Another way to do this is, that's a little bit more, it's a graphical method of doing this, is you can take a look at the proportion of points across your variables. So for example, you have a categorical variable and your binary target. What you can look at, maybe do some sort of bar graph saying like, all right, let's say I'm trying to predict accident severity as like severe or not severe, and then also weather condition, raining, not raining. So literally all you have to do is just plot 2 bars. I think the best way would be with like a stacked bar graph to just look at the proportion of zeros and ones in each class. I don't know if that makes sense. Let me see if I can draw it out here because I can't find my whiteboard marker anywhere. So if I had like a graph here, and this would be a proportion, you can normalize it as well. So let's say I have accident severity and sunny and rainy. So let's do, this is sunny. I figured this might be easier than writing the word sun, but it's not. And then this would be for rain. And between this, you have your zeros and ones. So let's say you have your, in sunny weather, you have like not so, or I guess severe being red. And I said, let's say for rain, you have more severe, and then not severe, let's go with blue, is a more common color. Maybe not severe looks something like that. So if you have bar graphs that look pretty different, it's pretty safe to say that you're not confounding. If you have bar graphs that look exactly the same, 2 things might be, what am I trying to say? If you have 2 bar graphs that look very, very similar, it might not be a good predictor. But if you have a bar graph that looks like, the other example I wanted to say is if you have a bar graph that looks exactly like this, then you have a perfectly correlated variable. And if you have this perfect correlated variable, you would say like, you can literally just use whether it's rainy or sunny to predict the severity of an accident, which is, I mean, great for your model. And then in that case, you wouldn't have to consider any other feature, but there's some implications there. So with that, your model might overfit and basically say that, all right, if it's sunny, it's definitely not going to be an accident, a severe accident, and you can lead to overfitting because sometimes there are accidents that happen when there's no rain. So with these highly correlated variables, you'll want to use different models, like for example, random forests that will randomly select subsets of features so that this will not be considered every time. So it is a very like case-by-case thing. But yes, I feel like I went on a lot of different tangents. My point to say is, if you want to see if something is directly correlated, or not, correlated is not the best word, but if something is a perfect predictor of your target, one, you can choose not to use it. to think about, is it a confounding variable? Because a lot of times they are confounding variables. And then also, if you want to keep it in, be mindful of what models you're using. If you're using a decision tree, it will pretty much always say your very first split is going to be this. And then you have like perfect purity, pretty much. Any questions about that? I feel like I just verbally dumped. So I'm going to like type this out here. Let me see. So confounding variables, take note of features that are a result of your target. And then with here, I would say bar graphs to check proportions. I'm going to screenshot this and also paste this in. And hopefully that is also helpful. Any questions on like thinking about your variables? Let's see if I can just drag this screenshot in here. There we go. Make this a little smaller. All right. Okay. Further questions. Which models require scaling of features? Logistic regression and k-nearest neighbors. K-nearest neighbors, you can definitely play around with the scaling. Wow, this predictive text is great. But then logistic regression, typically scaling works better. All the other models, you don't have to worry about scaling, but if you do scale, it really doesn't make a huge difference either. If our model is more about inference rather than prediction, is accuracy the best scoring method? Ooh, that's a good question. That requires a little bit of thinking. So if your model is more about inference, then yes, you do want to, I would argue that F1 score might be a better one, because accuracy is still, if something has a high accuracy, but you have imbalanced data, your accuracy can be high, but you're still not recognizing patterns in both or all of your classes. So I would say F1 might make more sense because it still takes into account both false negatives and false positives. Takes into account both F and FP, while accuracy, you can obtain a high score with a model that doesn't detect minority classes. Yeah, I would say that. I would say with this, it again, you want to think about like what is the context of false negatives and false positives, and are those things that you do want to account for. So yeah, you can argue. I would argue F1. I would say arguably, so it's not a fact. Okay. Next, similarities and differences between one-hot encoding and make dummies approaches to handling categorical data. So functionally, they do exactly the same thing. They just work slightly differently. This Stack Overflow that I had Googled and looked really quickly at, I think has a good summary of like pros and cons of each. I think one of the pros and cons that I thought about that wasn't in here is that if you're using one-hot encoding, you can actually make it part of your scikit-learn pipeline. So if you do the one-hot encoding, which comes from scikit-learn, you can have it as part of your pipeline. Make dummies, if you remember, or get dummies, comes from pandas. And so it's more for like your data frames. So again, they do the exact same thing. If you actually look at this, it does say that like your data types are, whatever your data types are, it matters. It's different for either method. So I think it says here for like get dummies, you want to make sure that your categories are strings, and then one-hot encoding, it doesn't matter, something or the other. I do recommend reading this. I actually like looked through a bunch of these and I think that these are really good explanations. So yes, functionally they are the same. they are the same, but require different data types and one hot encoding, you can make part of your pipeline. Any questions about that? All right, let's see. I don't think there is anything else. Let me do a quick scan through. All right. Let's see. I see a message from Tim saying that he read something that actually recommends one hot encoder over get dummies. For me personally, I don't care which one you all use as long as you're using them correctly. So yeah, feel free to take a read at Tim's comment in the chat. Let's see. Any other questions that anyone has maybe thought of?
What if both precision and recall are important for our case? Aish, I'm sorry, I can't hear you. Is it my end or?
Hello, can you all hear me now?
Yes, I can.
Perfect, thank you so much. I don't know what happened there. All right, okay, so I don't think I said anything else important. Right, so what I wanted to say was, I have something that I want to propose, but I'm not sure, again, it depends on you all. So the first topic of the next phase is principal components analysis, which is something that actually works really well with this project. So I do think it's a bit of a, it is unfortunate that it is in the next phase. So I propose that we could have an office hour and I can actually go through that material like fully, because the study group, like the materials that I prepared for that is not going to be more than like 40 minutes. So I was thinking and PCA basically will work very well with data sets with a lot of columns. So I was thinking if there aren't a lot of questions coming in, I will use one of the office hours, probably like Wednesday or Thursday, to talk about PCA. I'll put like a quick poll in the Slack channel to see if anyone has any strong opinions on that. But I think it would be something cool to incorporate. You don't have to incorporate it. Also happy to do it now and also when we get back into phase 4. So yeah, I'll put a poll into the Slack channel seeing what people are thinking about like dealing with PCA. But basically it's a method that will help you reduce the number of features without having to drop any of your features. So I will put a poll in the Slack channel. And if there's no like overwhelming no's, I will do that. All right, let's see. Does anyone else have any other questions or concerns about their project so far?
I'm sorry, I asked a question, but I think you lost my voice.
Yeah, no worries.
In some cases, both precision and recall are important for our project. What we can do in those cases?
Yeah, with both precision and recall, if both precision and recall are important, I would say, yeah, the metrics to look at would be accuracy and F1 score, because they both sort of look at it as like an overall. Like accuracy looks at your overall, correctly classified over incorrectly classified, and F1 is an average of your precision and recall. So I would say in terms of metrics, look at those. In terms of like, if you're thinking in like my model tuning, is there a different approach to model tuning if you're focusing on something overall versus either precision or recall? I think not really. I think your approach to modeling will still be very, very similar. If you have like imbalances, dealing with that should help across the board as well. But I think the main thing is for metrics, if both precision and recall are important to you, F1 score is a good thing to look at. But again, F1 is also just an average of precision and recall anyways. Right, anything else? Cool. Let's see. I think for this project, I think it is a good idea to really familiarize yourself with your data. I think EDA is something that a lot of people tend to overlook for this project. EDA can truly inform your modeling process. So I do recommend like spending maybe a full, like a half a day or a full day doing that. Yeah, just wanted to mention EDA. But yeah, I didn't have anything else I planned on talking about. If anyone has any last questions, if not, we can break early. And if you all have any other questions, feel free any time of the day to Slack me. All right, if there are no further questions, going once, going twice. All right, I will see you all tomorrow. Again, keep the questions coming on this questions doc. And yeah, have a good rest of your Monday, everybody. Bye.